Alright, I've been messing around with configurable joints for a few weeks now for my VR game, and I'm still struggling to wrap my head around how the heck they work. But I've figured some things out through this sort of test bed, and I want to share them because there's virtually no information out there on configurable joints, and the information that is out there is so simplistic as to be utterly useless. Like there's effectively zero information out there on these things. The official documentation is an abomination. It tells you less than nothing, just enough to confuse you. So let's just look at the official documentation first. All right, here it is. So for example, the anchor, the point at which defines the center of the joint. All physics-based simulations use this point as the center in their calculations. That is false. That is objectively false, not true at all. It's true for maybe like one or two things in here, but like this statement is false. If you go ahead believing this is true, you will never figure out configurable joints. There's other stuff like the projection mode, for example. This does not function if the joint is set to free, even though, you know, if you set the distance, the maximum distance I want is to be this. It will just ignore that if the joint mode is set to free. It has to be set to limited. I think even locked it'll ignore the project. I think it has to be limited and locked, or just limited, one of the two. I don't really use either of them. But this took me a while because I had started having to write my own code to handle projections because it just wasn't working. And the reason it wasn't working is it does not work if if that X motion, Y motion, Z motion, or the angular motion is set to free. It just will ignore it. Another thing, this enable collision doesn't function at all. I could never get by disabling collision, it just didn't matter. They would always still collide, so I have to encode manually make those objects not collide. This enable collision just does not function at all. Another thing, like the connected body here, this rigid body which the object connects to, you can set this to none to indicate the joint attaches to a fixed position in space rather than another rigid body. This is true. What they don't tell you is that the connected anchor depends on what this is. If there is a connected body, then the connected anchor is the location of the anchor is the local space of the connected body, not the anchor. Remember, this says this is the center of the joint. All physics-based simulations use this point. No, they don't. The fuck they don't. They use, if you have a connected body, this is the 0 point for the connected anchor. If there is no connected body, this is in world space. There is nothing in the documentation that tells you that. You just have to set your joint up, hit go, and watch everything explode, and then hit your head against the wall for a couple of weeks trying to figure out what the hell is wrong with it. Alright, so I built this sort of visual representation so that I could struggle to wrap my head around what is actually going on with a configurable joint. So this blue square is what I'm calling the body. This is the object that is going to have the joint on it. One quick note here, if you do swap bodies, it does change around, like the local positions are suddenly in the other object's local position. It's no longer in this object's local position. And if you configure in world space, honestly, you're on your own. Everything explodes when I do that. I don't know how to get configure in world space to work. So I'm not going to be swapping bodies. That means whatever object has the joint is the object that's, swinging, or it's the thing that's going to be manipulated by the joint. If you want the other thing to be manipulated, you would hit swap body. But for this example, we're going to not swap bodies because I want the thing that the joint is on, this blue cube, to be the thing that's being manipulated. That's still a little iffy because it will manipulate the other object. It's just the way that the math works. It's going to treat this as the end object of the joint. So the way this is set up, not using a connected body, so that means the anchor is going to be in local space of my body, and the target position is also in local space of the body. Now I've set up these cubes to represent those positions. I've got the body as the blue transparent cube. I've got an anchor that's the small yellow cube, and you'll notice that it's a child of body, so that as the body moves, the anchor moves with it. And then target is set to 0, 0, 0. That's also in local of the target cube of the body, and that'll be important as we go. The script that's on here, just a tiny little script on here called joint tester, and that's just updating the locations. So for example, it just takes the anchor object, the target object, the connected anchor object, which these normally you wouldn't have them as objects. I just put them as objects so I could manipulate them in real time to see what changing the values of these does, and then the actual joint itself. So for every fixed update, the anchor position is going to be the anchor's position in local space of my body. So inverse transform from point, or inverse transform point means take this world position and turn it into the local position of this object. Same with target position. I'm just getting the position of the target position object in my local space of the blue transparent cube. And then lastly, connected anchor is the connected anchor's position. Now, since we don't have a connected body, this is the world position. Connected anchor is world position if there's no connected body. If there is a connected body, then it would be the local position of the connected body. So if I had a connected body and this was vector 3, 0, it would be the location of that object, the source location of that object, the origin point of that object. Okay, so let's just go ahead and hit play and see what happens. So what the joint is attempting to do, you see here, it's attempting to make the anchor match the connected anchor. So if your target is 0, it tries to make the anchor and the connected anchor be right on top of each other. Now, because this is physics and this has some weight and gravity is enabled, it's pulling it down so they don't match quite on top of each other. You change your X drive, Y drive, Z drive to manipulate that. But if I start moving my target around, right now my target is currently, you look at the top right, you'll see position is 0, 0, 0. Currently the target is 0. That means treat the target as the offset of the anchor. So if I want to offset the anchor from the connected anchor by x1, I would set the position of my target to x1. And it's going to attempt to move whatever the offset of the anchor is, or whatever the target is, as the anchor. So it's going to try to move my anchor 1 to the x positive direction from my connected anchor. Now, since I've also got twisting, you'll see it twists and takes that into account, which is pretty cool. But that's what's going on here. So as I move my target around, you'll notice it almost looks like it's trying to keep the target in its same spot, but that's not what's happening. It's actually trying to keep the offset between the target location and the anchor. Now, you wouldn't actually you wouldn't have these as objects. I've just got this as an object so I can physically, move it around and see what happens. But in your actual joint, it's just going to be values. It's just going to be an X, Y, and Z position. And also for your rotation as well, if you wanted to change your rotation. Very interesting. Oh, because I don't, right, not driving rotation. That's basically all I wanted to show. That's what I was struggling to wrap my head around, the relationship between the object, the anchor, the connected anchor, and the target position. This is how they work. If your target position is 0, your anchor tries to move directly on top of your connected anchor using the forces of the joint itself. If your target is x plus 1, it tries to move the anchor plus 1 in the x from the connected anchor. Also, don't forget that your connected anchor is set in world space if there's no connected body. If there is a connected body, then the connected anchor is set in that object's local space.